In next 2 minutes, I will outline IBM Watson arc, why it shone early, why it later slowed in deployment, and what shaped the path. We'll cover 3 parts: reason for success and failure, key innovations and shortcomings, and limitations and bias. Next is reasons for success and failure. Review early wins and the latest bets on one cause and effect line. Watson excelled in competitions because the task and the metric were tightly defined. The pipeline joined retrieval representation reasoning, and the software hardware were tuned to deliver fast, reliable answers. Healthcare was hard because data is scattered and inconsistent. Privacy and integration add friction, and labeling and refresh demand ongoing investment. Complex clinical workflows limited impact if the system cannot slot into critical steps, and project style sales slow replications and scale. Next is key innovations and shortcomings. I will note strengths first, then gaps. 2 durable strengths answers came with evidence trails and confidence scores to support expert judgment, and capabilities were modular service that enterprise could assemble and plug into existing processes. Shortcomings followed. Dependence on high-quality domain data was underestimated. The evidence feedback loop was too thin for steady frontline adoption, and knowledge engineering lacked metric creation and updates. Reasoning maintenance cost over time. Next is limitations and bias. Data-side obligations, privacy interoperability, labeling, and distribution shift are continuous. Workflow-side alignment with real decision point is essential, and once embedded, system must withstand audit and revalidation. Bias can reduce effectiveness across regions and populations with sample are limited, and literature-driven knowledge can carry historical bias into automation. Bias management must run in parallel with modeling and deployment.
I'm Zhe Zhongzhu, and this case is about iTutor Group, an online tutoring company that used AI to screen job applicants. In 2023, the US EEOC found that the system automatically rejected women over 55 and men over 60. iTutor paid a $365,000 settlement, the first AI discrimination case in the US. The case shows that AI can make hiring faster, but without human checks, it can also make unfair decisions. We can also see 2 feedback loops from here. The first is a reinforced loop. Bias gets stronger over time. The system learned from old data that already had age bias, so it kept repeating it. The second is a balancing loop. New rules and public attention from the EEOC helped stop the bias. This shows AI needs outside control to stay fair. AI also helps iTutor work faster and lower costs, but it also spreads discrimination on a large scale. Many qualified people were rejected just because of their age. The case made companies realize that AI must be tested for fairness before use. Okay, now it's other cases. It's about the same lesson. IBM Watson was smart but failed in business. DeepMind worked well because it was open and ethical. Tesla's Autopilot shows that safety and rules are always needed. And iTutor failed because it used AI without enough human oversight. So, good technology must be guided by over-ethics. In conclusion, the iTutor case tells us that AI bias grows if no one checks it. Those audits and human review are the balancing forces that make AI fair and safe. At the EEOC side, automation is not nature, it copies human bias unless we fix it. Thank you.
Hello everyone, this is my part. The first part is case overview. This case is about how Google's DeepMind works with Morpheus Eye Hospital in London. They built an AI system to read 3D retinal scans and detect eye diseases. The main problem was that eye diseases were reading fast, but doctors were too few, so the goal was to make diagnosis fast and more accurate with AI. The project succeeded because it used a lot of labeled data and powerful deep learning. The AI had 2 parts. One found important parts in the image, the other made the diagnosis. This made the results clear and easy for doctors to check. Also, doctors and engineers worked closely, which built trust. It was new because the AI could match or beat top eye doctors in many diseases. It showed that AI can help doctors make decisions, not just replace them. But one gap is that data came mostly from one hospital, so we don't know if it worked as well in other places. This AI can help more people get fast and fair eye checks. It can reduce healthcare gaps between rich and poor areas, but it also raised questions about patient privacy because hospitals shared medical images with Google. AI can make mistakes if data are not diverse. It might misread images from people of different ages or races. Doctors might also trust AI too much. This is called automation bias, and privacy and ethics must always be protected. This project is a big step for medical AI. It shows how we can mix technology and care, but we must use it wisely.
Hello everyone, I'm presenting my case study on Tesla's autopilot accidents, covering the case overview, system dynamics, societal impacts, compressions, and key conclusions. Tesla's autopilot is a level 2 driver assistance system that controls steering, acceleration, and braking. Since its launch, it has been linked to multiple crashes, including some fatal ones. The main issue lies in limited perception, weak driver monitoring, and user over-reliance on automation. The system integrates cameras, radar, and ultrasonic sensors with neural network processing to perceive the road and make real-time decisions. It follows a loop: sense, perceive, decide, act, and learn. Yet, its vision-only design and inadequate monitoring creates a reinforcing risk cycle, where user trust grows faster than reliability. Autopilot brings both opportunities and challenges. Positively, it can reduce cortical-related crashes and improve mobility. However, it also raises concerns like job losses, public trust, privacy, cybersecurity, and broader ethic inequality. Compared with other firms, Tesla's strategy is unique. It drives rapid innovation and large-scale rollouts, speeding up learning but raising public risk. Others, like Waymo and Mercedes, take slower, more conservative validation approaches. The key lesson we can learn is to balance innovation speed with safety assurance. So in summary, Tesla's autopilot is a major technological step, but an ethically incomplete one. Accidents reveal gaps in safety validation, driver monitoring, and regulation. To progress safely, innovation must pair with rigorous testing, human-machine transparency, and strong global standards. Only then can autonomous driving evolve responsibly.
Now we move to our comparative analysis and conclusion, where we will synthesize key lessons from all 4 AI cases. We will cover 5 sections: overview, success factors, impacts, risks, and key lessons. Overview of key issues. So what works and what doesn't. Success needs clear boundaries. Know what AI can do. Good quality data, transparency, and humans must stay in the loop. Failures happen when data is messy, so the problem is too complex for the AI. Integration is difficult and there's no clear accountability. On the innovation side, cognitive computing, predictive AI, autonomous systems, but there are gaps. AI depends too much on training data. It can adapt well, so there's not enough traceability. For the impacts, both good and bad. There are better healthcare, more efficiency, but it also have discrimination, safety issues, and trust problems. There are 3 big problems: for technical limitations, data issues, system breaking in new situations, the integration challenges, for biases sources. Bad training data leads to discrimination. Attitude is a perfect example. For key risks, safety failures, privacy violations, and the big question is, who's accountable? So the conclusion is that balance innovation with safety, don't rush. Keep humans in the loop. AI should help, not replace. Make it transparent, no black boxes. Think about ethics from day one. Prevent biases. Don't fix it later. We need strong regulations. The bottom line is sustainable AI needs technology, ethics, regulation, and human collaboration working together. These lessons come straight from what we learned in the case. Thank you.